A single set of footprints may force us to redraw the map of our ancestors' journeys, and the evidence is hidden in stone across the globe. Stay tuned until number 1 for the most astonishing find yet. Unearthed in volcanic ash more than 3 million years ago, the Laetoli footprints capture a moment when early hominins walked upright across a Tanzanian plain. Researchers attribute the prints to Australopithecus afarensis, noting the clear heel-to-toe impression that suggests a bipedal gait remarkably similar to modern humans. The tracks were preserved when a sudden rain hardened the ash, locking the impressions in time. While the find confirmed early bipedality, recent analyses of stride length hint at a possible group movement, implying social coordination far earlier than previously thought. Up next, we travel to Southeast Asia for a footprint that challenges the timeline of Homo erectus.
Discovered in a riverbank deposit near Mojokerto, this tiny footprint belongs to a child of Homo erectus, estimated to be around 3 years old. The imprint measures just over 2 centimeters, yet it displays a distinct arch and toe separation that researchers say mirrors modern human foot anatomy. Radiometric dating places the layer at roughly 1.5 million years old, pushing back evidence of child rearing and family structures in early populations. Some scholars argue the foot's morphology could indicate a transitional form between Homo habilis and later Homo erectus, though debate remains. Next, we head to Spain, where a cluster of prints may rewrite the story of our European ancestors.
Hidden within the depths of the Sima de los Huesos cave system, a set of shallow depressions was identified as potential hominin footprints dating to roughly 430,000 years ago. The prints were found alongside a massive collection of hominin fossils, suggesting that a group may have entered the cavern during a brief foraging excursion. The stride pattern, though faint, appears to be shorter than that of modern humans, aligning with the robust build of Neanderthal relatives. If confirmed, these marks would represent some of the earliest known evidence of deliberate cave use beyond shelter, hinting at complex behavior. Following this, we explore a trackway that may predate even these prints.
Recent excavations in the Cueva de los Murciélagos revealed a narrow trackway preserved in a layer of fine limestone dust, dated to around 350,000 years ago. The series consists of 5 consecutive footprints, each showing a pronounced heel strike and a modest toe splay, characteristics associated with early Neanderthals. The spacing suggests a slow, deliberate pace, perhaps indicating a ritual or a cautious passage through a dark chamber. Some paleoanthropologists propose that the prints could belong to a small group moving together, challenging the notion that early hominins avoided enclosed spaces. Up next, we examine footprints from a waterfall that may push back the arrival of modern humans in Africa.
Scientists studying sediment layers near Kalambo Falls uncovered a series of footprints embedded in a thin silt sheet, dating to roughly 250,000 years ago. The impressions are shallow but display a clear heel-to-toe progression, with the big toe positioned slightly inward, a trait linked to Homo heidelbergensis. The location near a perennial waterfall suggests that early humans may have been drawn to reliable water sources, supporting theories of settlement patterns centered on resource-rich zones. The prints also reveal a consistent stride length, implying a group of individuals traveling together. After this, we move to North America, where a lone print could rewrite the timeline of early migration onto the continent.
Surprisingly, a single, well-preserved footprint was found in the dry lakebed at Murray Springs, dated to about 13,000 years ago, within the terminal Pleistocene. The print belongs to a small, child-sized individual, as indicated by its modest size and the delicate arch. Its morphology aligns more closely with early modern humans than with the earlier Paleo-Indian foot structure, suggesting rapid anatomical adaptation after the first entry into the Americas. Some researchers argue the find may point to earlier, possibly coastal, migration routes that have yet to be uncovered. Next, we travel to Indonesia for a footprint that could change the story of Homo sapiens in Southeast Asia.
Intriguingly, a set of 3 parallel prints was uncovered at the Sangiran site, embedded in a mud layer dated to roughly 1.2 million years ago. The size and shape correspond to Homo erectus, yet the stride indicates a longer step than typical for that species, hinting at a possible regional variation in locomotion. If the interpretation holds, it could suggest that early Homo populations in Sunderland adapted to a more open, perhaps coastal, environment, contrasting with the forest-dwelling model traditionally assumed. The find also raises questions about the speed of dispersal across the Indonesian archipelago. Coming up, we investigate a Neanderthal footprint on the edge of Europe.
Remarkably, a solitary imprint discovered in the limestone cliffs of Gibraltar has been linked to Neanderthals living around 40,000 years ago. The foot shows a broad heel and a pronounced lateral toe spread, traits characteristic of Neanderthal foot anatomy. Its depth suggests a heavy footfall, possibly from a person navigating the steep terrain while hunting. This footprint provides rare direct evidence of Neanderthal presence in the region during a period when modern humans were also expanding into Europe, offering a tangible glimpse into potential interactions between the two species. After this, we head to Australia for a find that may shift the timeline of early settlement.
Finally, a faint yet distinct footprint was recovered from the Lake Mungo Basin, dated to approximately 42,000 years ago. The print belongs to an adult, as indicated by its length and the clear impression of the arch. Its morphology aligns closely with that of modern Homo sapiens, supporting the view that anatomically modern humans were present in Australia earlier than some estimates suggest. Moreover, the location near a water source hints at strategic settlement choices. Some scholars argue that this could indicate a coastal migration route, challenging the inland corridor hypothesis that has dominated Australian prehistory. Up next, we reveal the most groundbreaking footprint of the list.
Ultimately, the Borneo coastal footprint, discovered on a now submerged shoreline in Malaysia, may be the most paradigm-shifting find of the decade. Radiocarbon analysis of surrounding shells places the imprint at roughly 70,000 years ago, predating the widely accepted timeline for modern human arrival in Southeast Asia. The print measures about 26 centimeters long, with a pronounced arch and a distinct big toe alignment that matches modern Homo sapiens foot structure. Its preservation in tidal mud suggests the individual walked along a coastline that has since risen due to tectonic uplift. If the dating holds, this would imply that modern humans reached the islands of Wallacea far earlier than the conventional out-of-Africa model predicts, opening new discussions about maritime capabilities and migration pathways. This extraordinary evidence underscores how a single step can rewrite chapters of our collective past.
These 10 ancient footprints remind us that the story of human migration is far from finished, each imprint offering a clue to routes once taken and cultures long vanished. By following the trail, we glimpse how adaptable and far-reaching our species truly is. If you enjoyed this journey through time, subscribe so you don't miss the next mind-blowing list we release each week. Which discovery reshaped your view of early humanity? Let us know in the comments, and if this video sparked your curiosity, give it a like. Thanks for watching.